welcome to our beautiful channel Mission MBBS. Here I have taken a mission to accomplish all of our goals that we have taken in our life. May God help me in doing that properly. Well, my channel is still a newborn baby, so please nourish it with your support. I leave no stone unturned to quench your thirst of knowledge. With this saying, let's move on. Here we go. So, today we are going to study about the usage of dimensional formula. The first use is to check the correctness of physical equation. Now to check the correctness of physical equation, we need to have one concept in our mind, that is the dimension of a physical quantity on either side of a physical equation must be equal. It means that if a physical equation is a plus b equals to c, then a dimension either side should be same. I mean to say each term should have similar dimension, and this concept is called principle of homogeneity. Suppose the dimension of A is L, B is L and C is L, means here all of them are same. So dimensions should be always same of each term of the physical equation, separated by plus, minus or equals to. So that's the concept of principle of homogeneity. That is, dimension of LHS should be equal to dimension of RHS. Now let's take one example. I have taken an example of equation of motion b square equals to u square plus 2as. So taking LHS side, we get v square, its final velocity. So the dimensional formula of velocity is L t to the power minus 1, and this is whole to the square. So we will get this L square t to the power minus 2. This is the dimension of v square, or that is LHS side. Now taking the RHS, that is u square plus 2as. Now it is initial velocity, so velocity same dimension, it will be here Lt to the power minus 1 and whole square, and here acceleration and distance, so that dimension will be keep here, and 2 will be as it is dimensionless, it's numerical part, so it is dimensionless, so it will be as it is. Now you see that this dimension and this dimension, all of them are same. So in this case, the given equation is said to be correct dimensionally, not physically. The given equation is dimensionally correct. Even if we keep here 4 in place of 2, then also dimensionally it will be correct, but physically it will be incorrect. So keep one thing in your mind, that if an equation is dimensionally correct, then it may not be physically correct. But if an equation is physically correct, then it will be dimensionally also correct. And another concept should be there, that is dimensional formula can neither be added nor be subtracted. So we cannot add dimensional formula with each other, neither we can subtract it. Now you will say, can we multiply it, can we divide it? Yeah, we can multiply it, we can divide it, but we can never subtract it or add it. So dimensional formula can neither be added nor be subtracted. So this concept should be there in your mind. Now let's move on. We can take another example. I have taken here time period of the simple pendulum t equals to 2 pi root L by g. So here also the dimension of time is given here in LHS side. In RHS also L will be cancelled and we will get the dimension of time. So both of them are same, so it is dimensionally correct. Now in place of 2 pi, if we will keep something else, then also it will be dimensionally correct. It's assistant level type. Suppose I am a teacher, I will check some paper, and after totaling I'll give to my assistant. Now what the assistant will do, they will recheck all the totaling marks, and they can only say that, yeah, I have not given the total mark correctly or incorrectly. They cannot complain that why you have given less mark in particular question, or you should give some more mark to this particular student. They cannot complain that. They will only check whether totaling is true or not. So that's what a dimensional formula does. A dimensional, it can check whether it is true or not, but physically the formula may be incorrect. So keep this in mind. Now next use of the dimensional formula is to convert a unit from one system into another. So for that we will use this formula. Now let's see how this formula came. Let's see it in rough. Here I said that to convert a unit from one system into another. So from one system, for example, from CGS system to SI system and so on. So in previous lecture I had taught this to you. The physical quantity expression is n into u. N is the numerical value, u is the unit, isn't it? So same formula we will be using here. In the first system, the first system that is given, in let x be the physical quantity, then it will be n1 into u1 in the first system. And in another system that we are given to change, means we are changing one system into another system. So the another system, let x be n2 into u2. So here numerical value will remain as it is. It has no dimension. Numerical value never has dimension. Suppose we have 1 kg of salt. So 1 is numerical value, it has no dimension, but kg it will have dimension, isn't it? Same is the case here. So u1 will have dimension in terms of ml and t as given here. Same will be the case here. We'll let it m1 l1 t1 abc as it is, and m2 l2 t2 and abc as it is. And when we will equate this both equation 1 and equation 2, then we get this formula. Now by using this formula we can change unit from one system to another very easily. I have shown that one few example to you. Go through it once. Let's go through this. So we are converting 1 dyne into Newton. So let 1 dyne equals to n2 Newton. This 1 means n1, and here n2 we have to find it out, and unit we are given dyne and Newton. Now for this, first of all we should know the dimensional formula of force, because these are the unit of force. So you need to know the dimensional formula of force. By using that we'll find it out. If you know the dimensional formula of force, you can solve it very easily. I had said it to remember in the previous video. If you want to watch it, then type unit and measurement mission MBPS, you will get that video. There I have given a complete list of all the dimensional formula. So here in CGS system, n1 is 1 in dyne 1, and m1 l1 and n1 t1 is 1 gram, 1 cm and 1 second respectively. In SI system n2 we have to find, and m2 l2 t2 will be 1 kg, 1 meter and 1 second respectively. Then from equation 2 we have given this. We'll compare. This will be a, power of m will be a, power of l will be b, and power of t will be -2. And then according to the conversion formula, then we will use the conversion formula, and putting all the values we'll get this. Here in place of kg we'll write 10 to the power 3 gram. We know this 1 kg equals to 1000 gram, isn't it? 1 kg equals to 1000 gram. So this we can write 10 to the power 3 gram. These two are the same, so same thing I have written here. In place of it, 1 meter equals to 100 centimeter, so in place of 100 we will write 10 to the power 2 cm, and same is the case. Second is remains unchanged, and then this will go up, it will be minus 3 minus 2, and then we will get 10 to the power minus 10. Similarly, go through this example. I hope you are clear about these two uses. In the next video I will come with one more usage of dimensional formula and some limitations of dimensional formula. Till then, thank you.